So when they have stuff in common or overlap, these are not disjoint events, which means we have to tweak our event itself. So whenever they're not disjoint events, this is our equation for non-disjoint events. It is the same process, right? We still add both of them together. However, now we subtract what they have in common. Okay, so that's the overlap when it comes to it. So if we go back to our example over here, right here, we were actually counting more cards than we actually had, right? So we were counting the eight, what's it? Two cards that were 8 in here, and two cards that are 8 also in there. You guys see that? Because we're double counting, so in order to cancel out this portion, we actually have to subtract this and not actually add it to itself. So how that corresponds to it is, well, that's where this add comes into play. It's what they actually have in common. So again, the probability of A and B is the probability of event A and B happening or occurring at the same time. So now let's go back to the last question and let's tweak what we actually did before. So it's the same process we did here, right? It's still that portion, but now I must subtract everything they have in common. So we got to figure out what do they have in common. So there's 4 cards total they have in common out of 52, right? 2 of them come from their 8s that are also reds, and 2 other ones that are 8s that are also black, which means our actual equation should look like this. So this is from what we did earlier, and this is the probability of A and C and D all put together, which means after we add subtract total, we get 52 over 52, which is good, right? It's 1. So which means it's still pretty good. It's exactly what we want, right? So that's what happens when it comes to it. So now when it comes to the OR events, you have to do 2 things. Is the events disjoint or not disjoint? Because now that gives you, that makes sure you have to use which equation you actually have to do when it comes to it. So why don't we try question 3 out to see which one we're going to do in here, okay? So question 3 says, using a deck of cards again, A says, what's the probability of getting a diamond or a king? Okay, so A, the ORs, right? So here's a question. Are the events disjoint or not? Meaning, can you get a diamond and also a king? Hopefully you say yes, right? You can get a diamond that says king. So which means we have overlap. So we're going to subtract some stuff. Okay. So first off, we're going to do individual probability. So what's the probability of getting a diamond? So there's 13 diamonds out of 52. Plus how many kings are there? There are 4 kings out of 52. Now we're going to subtract how many cards are kings and also a diamond. And that's only one of them, right? Out of 52. And now all we're going to do is add, subtract the tops, and we get a final answer of 16 over 52 as our answer for this. So again, we always have to track the overlap when it comes to non-disjoint events. Okay. So why don't you guys try the rest of them, B, C, and D for extra practice. So let's do a quick pause of this video. So 3, 2, 1, pause. Okay, so hope you guys try these out. Let's try B out. So find the probability of getting an 8 or a heart. So A is an 8, and B is a heart. Okay, so probability of A or B. Well, there's 4 cards that are 8s. There are 13 cards that are hearts. Now, what's the overlap? Well, how many cards are 8s and also hearts? There's only 1. So it's going to be this, again, 16 over 52. That's your answer. Okay. All right, let's go to C here. So what's the probability of getting a red card or an ace? So this is ace and a red card there. So probably A or B. So red card, there's 26 red cards out of 52. There are 4 aces. And now how many aces are red? Well, there's one that's a heart of aces, and there's another one that's a diamond of aces. So that's 2 cards. So that's what we subtract. So our answer is going to be 28 over 52. Okay, and the last one's a little difficult because we have more than 2 events happening here, right? What's the probability of getting a club or a diamond or a 10 or a queen? That's a lot of stuff, right? But then Notice the or, right? So or means addition, so we're adding stuff together. So we'll say this is A, B, C, and D. Okay. All right. So what's the probability? So I'll just say all for short. So what's the probability of getting a club? There's 13 clubs out of 52. Probably getting a diamond. There's also 13. How many tens are there? There are 4. Queens, there are 4. All right. So now we have to subtract some stuff, right? So let's just do it individually. Is there any way I can get a card that's a club and also a diamond? No, right? So we're good there. Okay, so let's move on. How many clubs are also tens? 1, right? 10 of clubs, okay? How many clubs are also queen? Also 1, right? Okay, now let's go on to here. How many diamonds are also tens? There's 1. And then finally, how many diamonds are also heart or also queens? 1. So we're subtracting each one individually, right, when it came to it. So again, after we add, subtract all of these together, we should get, what, 26, 30? 30 out of 52 is your answer. Okay. All right, so hopefully it wasn't too bad when it came to it. So now let's do a different type of scenario. Okay, so it kind of got cut off on me when it came to it, but for our case, it's the question 4 at the bottom. Again, back to the polygraph test. I'm say no, yes, lied. Lied. Not lied, for short for me. Okay. All right, so here's a question. If one of the subject was randomly selected from the 98 subjects, find the probability of selecting a subject who had a positive test or. Okay. So here's the or. So this is A, this is B, right? Positive test. Okay. So let's see. So it's an or, so it's addition rule. So the probability of A or B. So how many people got a positive test? That's right. So positive test. So that's going to be total here, 57. So 57 over 98 plus. How many people lied? So that's down here. So that's 51. So 51 over 98. Now here's a question. How many people, right? So we have to figure there's overlap. So is there overlap in this question? The easiest way to figure this out is making some circles. And what I mean by making some circles is just drawing out your actual events. So what I mean by that is my first event is that, right? People who got a positive test. My second event is people who lied, which is these people here. So here's a question for you guys. How many people got a positive test and also lied? And hopefully you say 42. Or notice the overlap, right? It was the whole process of that, right? We subtract the overlap. So that means, yes, there is overlap. It means we have to subtract some stuff. So we actually subtract 42 people out of the 98 for the double counting. Now we add, subtract according to what we have. Okay. So once we add, subtract accordingly, what do we get? Let's see. We get 66 over 98. And there we go. Or approximately 0.673 decimal. Okay. All right, so let's keep going. Let's try question 5 now. So this is actually a pretty interesting question itself. So the professor of a Physics 250 class said that out of the 85 students in the class, only 8 will get an A, 14 will get a B, 20 will get a C, 24 will get a D, and 19 students will get an F. Assume getting any grade in the class was equally likely to happen if a student was randomly selected What is the probability that student will pass the class with a C or higher? So or, right? There's our keyword, or. The last question is, would a student have a good chance of passing the class? All right, so C or higher. So, okay, what's a C or higher? So what's higher than a C? So we get a C, B, and an A, right? Those are the letters higher than a C, right? C or higher. Okay, so we want the probability of A, or getting a B, or getting a C in this class, right, when it comes to it. All right, well, let's figure out how many people will get an A in this class. Well, according to the data, it says only 8 students will get, so 8 out of how many students in the class? 85. How many students will get a B in the class? Well, it says 14. And then finally, how many will get a C in the class? And it says 20. All right, so we just add in this case, so 20 plus 14 plus 8 gives us 42. So what are your odds once you divide? 49, 4. Not even a 50% chance of passing the class just on sheer luck. That's not good, right? So would a student have a good chance of passing the class? Well, I would say no, right? This is an open-ended question, but, probably is no, right, when it comes to it. Okay, so this is your answer. There you go. Okay. All right, so this number 6 is a pretty lengthy one when it comes to it. So why don't you guys try question 6 out, and then we'll do it together in the next video.